All right, this is part 2 of our review for the final exam, starting with question number 26. 26, what is the resistance of a circuit that uses a 12-volt battery to power a 372-watt motor? So we're looking for the resistance, and I had gotten started here to just wrote down this is a two-step program or two-step problem. The first step is to use the information that we have, which is we have the voltage and we have the power. So we can use power equals voltage times current, which is 372 watts equals the voltage is 12 volts times our current, which we don't know. So we can divide both sides here by 12, and that's going to give us the current, which would be 372 divided by 12 is 31. And that would be 31 amps. And then our second step of the problem is to use Ohm's law, which is voltage equals current times resistance. And we're looking for the resistance. So we already given the voltage in the first part there, which is 12 volts, equals the current we just calculated, that was 31, and we don't know what the resistance is. We're going to isolate the resistance, divide both sides by 31. 12 divided by 31 gives us 0.387. We'll round that off to 0.39 ohms. So where do we put that? 0.39 ohms. That would be our answer for question number 26. Number 27, draw three light bulbs connected in a parallel to a battery. So I'm just going to use my symbols for my battery. There's my symbol right here, and this is in parallel. So let's just use this kind of a like this, and let's make this our bulb. And we have a second bulb here. There's supposed to be a squiggly line in there, and a little bit small to be doing that, but that's what it would look like right there. 3 light bulbs in a parallel. Number 28, 3 light bulbs in a series. So for number 27, this is just a parallel, it's just having 3 different pathways. And for a series, it's just 3 light bulbs in this case, and they're all in a single pathway. And the circle with the squiggly line through it is just a symbol for a light bulb. Draw a diagram showing how to connect a voltmeter to a motor and battery circuit to measure the voltage. So this would represent a voltmeter, and in order to do this, basically what we want to do is we want to have a complete circuit, right, from the battery to the motor to get the motor run, and then this would be your red, and it could go to either one of these. Okay, so I'm not using. This would go to this one right here, and that's how and it could be anywhere along there. You could be measuring it here and here rather than here and here. You could be measuring it here and here. You just have to be measuring on the 2 different wires. Okay, and the next one here is, let's see, draw a diagram to show how to measure the current. So with the current, what we want to do is we want to make the meter part of the circuit. Okay, so you're connected here, and just like that. So the meter, the electrons, the electricity are flowing right through the meter. There's a wire in here connecting the the meter from one side of the meter to the other side of the meter. Okay, so measuring voltage, we measure voltage across the circuit, And what we just did up on the one here, number 31, for the one that we just did up here, we were measuring the current, okay, and you measure the current through the meter. Again, so we measure through the meter. In other words, we make the meter part of the circuit. Number 34, show your work on a paper. You have an 8, 12, and 20 ohm resistor connected in a series to a 12-volt battery. Okay, so whenever you do these, I think probably it makes the most sense to just go ahead and make the little diagrams that we did in our assignments. Okay, I think that probably will make it easier for you. This is resistance, and you've got an 8, a 12, a 20, and a 12-volt battery. And this is your total here. So this would be 12 volts. This is voltage, and this is the middle one is current. So that's the information that you have. The total resistance on a series circuit. Okay, make sure that you're paying attention to what kind of a circuit is, because the rules change between a series and a parallel circuit. So for on a series circuit, resistance adds up. So this is pretty easy. You've got an 8 and a 12 and a 20. And you just add these all up, and you get 40 ohms. So that's one of your answers right there. Question number 35. What is the current through the 12 ohm resistor? Okay, current through the 12. What is the current through the 12 ohm resistor? Okay, so we have to find out what the total current is here by using Ohm's law. Voltage equals current times resistance, because if we can find the current in one spot, we can find the current in anywhere here, because current is the same through the whole circuit. So we use the total voltage is 12 equals the current we don't know times the resistance is 40. So divide both sides by 40. 12 divided by 40 is going to give us is 0.3. This is 0.3. So that's this right here. Okay. Excuse me. But remember, on a series circuit, current is the same everywhere. So it's asking, what is the current through the 12 ohm resistor, which is the middle one up here. But since it's 0.3 on the bottom here, it's 0.3 here. It's also 0.3 here. It's also 0.3 here. Okay, so the answer to that is 0.3. Answer up here was 40. What is the voltage across the 12 ohm resistor? Okay, well, we can use again our Ohm's law. Voltage equals current times resistance, and voltage equals 0.3 times the resistance at that spot is 12. 0.3 times 12. 0.3 multiplied by 12 gives us 3.6. 3.6 volts. Okay, this one here, now we have a parallel circuit for these questions here. We have a 5 ohm, 10 ohm, and 20 ohm. Let's go ahead and draw this here. We have a 5, a 10, and a 20 ohm resistor. And we have a 24 volt. This is position 1, position 2, position 3, and T is for the total. Okay. What is the voltage across the 20 ohm? Oops. 5, 10, and 20 here, not 12. What is the voltage across the 20 ohm? Well, we need to know more information here in order to do this. So, well, we have the information that we need, but we're going to have to find the total resistance in order to do this, in order to find this problem here, this answer here. We've got, no, actually, I guess we don't, because in a parallel circuit, the voltage is the same everywhere. So we've got 24, 24, and 24 for our voltage here. The voltage is the same everywhere, so it's asking, what is the voltage across the 20 amp or 20 ohm resistor? Well, it's going to be 24 volts. And what is the current through the 20 ohm resistor? So this is where we can use Ohm's law. Voltage equals current times resistance, and we know the voltage is 24 volts. The current we don't know. The resistance is the 20 ohms, and we can isolate the current by itself by dividing both sides by 20. 24 divided by 20. 24, we want to divide by 20, gives us 1.2 amps. 1.2 amps. This one up here was 24. Let's see, the next one here, we have the winch. Okay, don't forget about our winch problems. And we're given information that this winch used 7.5 volts, had a current of 0.74 amps. The mass that's being lifted here is 40 pounds. Just like in the lab that we did, we lifted it 5 centimeters, and the time it took was 7.1 seconds. Okay, so the first one here, number 39, what is the input power? Okay, so power in equals the voltage times the current. And we're given the voltage is 7.5 volts times the current is 0.74 amps. Voltage and amps. And 7.5 times 0.74. 7.5 multiply 0.74 gives us 5.55. 5.55, and voltage times current is our unit of power, which is watts. That's what the W stands for. How many meters are in 5 centimeters? This is a conversion we've done many times already. 5 centimeters. We want to use our conversion factor, which there are 100 centimeters for every 1 meter. That will cancel centimeters out. 5 times 1, that's the top times the top, gives us 5. And 100 on the bottom. 5 divided by 100 is 0.05 meters. And probably didn't even have to do that math because you guys knew that in your head. How many kilograms are in 40 pounds? Again, you've done this many times. 40 pounds. And there are 2.2 pounds per every 1 kilogram. Okay, units cancel out. Remember, whatever unit you start with goes on the bottom of your conversion factor. 40 pounds times 1 is 40. 1 times 2.2 is 2.2. 40 divided by 2.2. 40 divided by 2.2 is 18.1818. We'll round that off to 18.18. 18.18 kilograms. Number 42, the force needed to lift 40 pounds. So we need to convert kilograms to newtons to find out what the force is. Okay, so we have 18.18, and we're taking into consideration here the force of gravity, which is 9.8 newtons per 1 kilogram. These were kilograms over here. Kilograms cancel out, so we have 18.18 times 9.8. 18.18 times 9.8, 178.164. We'll round that off to 178.16. And that's newtons. Work. Let's just keep putting a box around these answers here for you. Work equals force times distance. We just calculated the force, which is 178.16 newtons, times our distance is up here, question number 40.05 meters. 178.16. 178.16 times 0.05 meters, 8.908, 8.91. Newtons times meters is joules. Unit of work. What is the output power? Power out equals work divided by time. We just calculated the work, 8.91 joules, and the time was given up on the top here, 7.1 seconds. So that was given right in the problem itself. Joules per second. .9 8.91 divided by 7.1 is 1.25 joules per second. That is also watts. Efficiency, percent efficiency equals power out divided by power in. We just calculated the power out, 1.25 divided by the power in. We calculated that way up on number 39, 5.55. 5.55. Our answer is going to be multiplied by 100 to turn it to a percent. 1.25 divided by 5.55, and we're going to multiply that by 100. 22.52%. 22.52%. There you go. If you have questions on any one of these, shoot me an email. Let's get this right. This is very similar to what the test will be like next week. Good luck.